Hello friends. In this video we are going to solve a problem based on the measurement of medium resistances using the ammeter voltmeter method. So let us start with our problem. So our problem is we are measuring a resistance using the ammeter voltmeter method. In the ammeter voltmeter method, there are two connections. So here in the question we are given that the resistance of the ammeter it is 0.01 ohm. So we can write here that the resistance of the ammeter, that is RA, its value is given to us as 0.01 ohm, and that of the voltmeter is 2000 ohms. So RV, that is resistance of voltmeter, is 2000 ohms. Now in out of the two combinations, in case of the second connections, the current measured is 2 ampere and the voltage is 180 volts. Now we have to find the percentage error in calculating the value of R as a quotient of the readings and the true value of R. Also, we have to find the reading of the voltmeter in the case of first connection when the current indicated by the ammeter is 2 amperes. So let's try to solve this problem, that how we can measure the resistance using this ammeter voltmeter method. So first of all, we will draw the circuits for the two connections in this method. Here we will be having a voltmeter. This is the power supply which is providing the current and the voltage to the resistance. Okay. So this is the first connection, and in the second connection, here the difference between the two connections is that in the first connection, ammeter is connected close to the unknown resistance, and in the second connection, voltmeter is connected close to the unknown resistance. So in the first case, the voltmeter, it is going to measure the voltage across this ammeter also and across this resistance also. So here it is going to measure VA and VR. So in this case, the voltmeter, because we know that what is resistance? Resistance is the ratio of voltage and the current. So voltage reading we are getting through the voltmeter, and current we are getting through the ammeter readings. So voltage, by dividing their readings, we can get the resistance. But in the first case, the voltmeter, it is going to give us the readings VA plus VR. And in the second case, total current is I, but here we are having IV, the voltage across the current across the voltmeter and the current across the resistance. So I will be equal to IR plus IV. I remains the same here, and here V remains the same. So when we are measuring the value of resistance, that is Rm, we will get VA plus VR upon I, and here we will get the measured value as V upon IR plus IV. Okay, so in both the cases we are getting the measured value different from the true value of the resistance. Now let's again coming to our problem. In our problem, we are given the value of the resistance of the ammeter, resistance of voltmeter is given to us, and we are given that in the case of second connection, the current measured is 2 ampere and the voltage is 180 volts. So in the case of second connection, if we measure the value of resistance, So measured value of resistance will be equal to voltmeter reading divided by the ammeter reading. So Rm, because it is in the case of second connection, so we are writing Rm2, it will be equal to V divided by I. Now V is given to us in the question as 180 volts and I is given as 2 amperes. So we are getting the value of the resistance as 90 ohms. Now, because as I have said that in the case of second connection and the first connection, we are not measuring the true value. Here the measured value will be the V divided by IR plus IV. So here we are getting the current reading as the ammeter reading as 2. So I will be equal to, so here because I will be equals to IR plus IV, so we are going to measure the voltmeter current. So IV will be equals to V divided by RV. Now voltmeter reading voltage was 180 and the voltmeter resistance is 2000 ohms. So current across the voltmeter will be 0.09 amperes. Okay. Now we know that the ammeter reading we are getting as 2 amperes. So 2 ampere will be equal to IR. We don't know. IV is 0.09. So through this we can calculate IR. IR will be 2 minus 0.09. So it will be, here we will get the value of IR. Okay. It will come out to be 1.91. Okay, amperes. Now if we calculate here, IR will be equals to V divided by R. Okay, so R can be calculated as V upon IR. V is again 180 and IR is what, 1.91. So we will get the value of resistance as 94.24 ohms. Okay, so what we have done, we know that the measured value of resistance is the voltmeter reading divided by the ammeter reading. So Rm2 will be equal, we have calculated it as 90 ohms. Now I equals to IR plus IV. We know that in the case of second connection, the ammeter is not measuring the true value, but it is measuring the sum of the currents here. So I equals to IR plus IV. IV we calculated here, then we have calculated IR, and through IR we calculated the resistance. Now you can see that the true value of the resistance is 94.24 and but the measured value is coming out to be 90 ohms. So there will be an error in the measurement. You can see that the measured value is less than the true value. So error in the measurement can be calculated. If we measure the percentage error, then it will be true value minus the measured value divided by the true value multiplied with 100. So here true value is what? 94.24. The percentage error, it will be the value which is coming out to be 94.24 and the measured value is 90 upon the true value is 94.24. So it is coming out to be 4.5% approximately. Now we in the question we were asked that we have to find out the percentage error and also we have to find out the reading of the voltmeter in the first connection when the current is 2 amperes. So in the first connection The voltmeter, it measures the sum of the voltages across the ammeter and across the resistance. So V is equals to VA plus VR. Now what is VA? That this is I multiplied with the resistance of the ammeter, and this is I multiplied with the resistance. Taking I common, we are having RA plus R. Now, ammeter reading is given to us as 2 amperes. RA, that is resistance of the ammeter, is 0.01, and the value of resistance, true value, is 94.24. So when we solve this, we will get the voltage or across voltmeter or voltmeter reading as 188.50 volts. Okay. So in this way, we can measure the resistance using the various equations. We can measure the true value. We can calculate the true value of the resistance, the measured value of the resistance. We can calculate percentage error also, and any of the unknown variable can be calculated by using the formulas for it. Just we have to remember the circuit diagram, and we have to keep this thing in mind that in the first case, voltmeter is measuring the sum of the voltages across the ammeter and the unknown resistance, and in the second case, the ammeter, it is measuring the sum of the currents across the resistance and the voltmeter. Difference is there. So when this concept will be clear to us, we can easily find out the measured value, true value, percentage error in both the cases. So I hope that this problem is clear to you. Thank you.